from Charlotte. Or somebody.
You're reminding me that Tony told me to close all of my things that make sound.
I think Peter's jumping on at some point. You know, it's nice to have like an even gallery view of people, right? It does something for the brain to have it lay out nice, but
it's a very tired Brady Bunch.
it is a very tired.
How's everyone doing?
Well, not bad. Like weather's been great today for a change, so
Nice.
it's been, yeah, it looks like summer finally arrived in Helsinki, so which is kind of a big thing. It stays, the winter is so tiresome and so long that when the summer finally, I guess the first time it went above 20, like all the parks were full. I guess it could have been Ebola outside. People would go out like it doesn't matter. In Helsinki, good weather, like there's no reason to stay home. Like you don't get many of those. So
yeah, you gotta use them when they come. Even around here, I feel like we really only get 20 good days a year. 20 really great days, you know? So we've been having a couple of them recently. I'm like looking out the window being like, I should go outside, not program.
Yeah, I already been to the park today. I had a quick walk there. Nah, you can't miss it.
I like walking like after it's dark here because there's so many less people. It used to be like it's like we're in a not very dense neighborhood. Not a lot of people. Now we just have to constantly dodge people in our neighborhood.
Yeah.
There he is. Hey, what's up, Peter?
Peter.
He's in the middle of nowhere, Maryland. I don't know if his network is strong.
Here we go.
There you go.
Does Maryland have a middle of nowhere?
Apparently.
Peter, it says Pegter on your thing.
Yeah, I know. I was just fixing that. Well, it comes up under my wife's name first, so I was like, well, that'll confuse people further. So we'll just. Anyways.
Can I just test? Can you hear me? Okay.
Yes.
Yes.
Great.
So I feel like I've met you once, Charlotte, somewhere. Maybe when you were at Edinburgh at the Daffix thing we did there.
Yeah, I was helping organize that, so probably.
Yeah.
Yeah, a couple of faces also look familiar, but I'm terrible at placing folks, so I apologize in advance. I may have met you before.
No problem.
I'm pretty sure we also hang out in Trondheim for a while.
Yeah.
Yes.
And Rossi, I know I met you at Daffix because now I remember your face, and I remember chatting at a bar.
Yeah, we were at some underground, like it was a bar that you had to go down. It was a pub, but you had to go down. I've never been to a pub that you go down. Like, not many pubs are like normal there, but it was in Birmingham, yeah, this year. It was a great time. Yeah.
We have a lot of down pubs in New York City.
Yeah.
Well, okay. Yeah, this is not a thing here, at least all the places I've been. Not really many underground pubs.
All right.
Probably safer than pubs where you have to go down, where you have to go down the stairs coming out, you know?
Yeah.
Like better be going up the stairs after you've been in the pub.
Yeah, that's true. Going upstairs, leaving the pub is definitely more problematic. Good time. Yeah, but it was actually my first Daffix because I'm like I don't have like I would say the typical DSP engineer background. Like I haven't been through academical life or anything. I just finished college and started working coding, and then I came like I was always studying audio on the side, and it only came to actually doing for a job like a few years after I was actually coding. So that it was my first Daffix. When I went to ADC in London. It was my first time meeting most of the audio guys. So I feel that sometimes like I'm a newcomer, even though I have been studying audio for like 10 years. Like, I feel like a newcomer in the scene, I guess.
I think everyone has a first Taffix. I don't know if that's a
Memorable.
controversial statement.
I've never even been, so
You should
It's
come.
a shame.
The outsider.
okay.
Hey James, we're good to start, right? Invisible James.
I think
Let's go, he says. Let's go. I'm looking at the chat. All right. So we are officially started. So here we go. I'm Russ. I'm one of the lead DSP guys, or the lead. I don't know. Our titles are fast and loose at Eventide. I've been there a while. Been doing DSP. The guy in the box below me, at least from my reference, used to be my boss, but now he owns Newfangled. But here he is. He's waving. I'll kind of lead us through some short introductions, and tell us, who your name, who you work for, what your interests are, signal processing or math or otherwise, or audio, and we'll just go from there. We don't have much of an agenda. So like I said, I'm Russ. I'm drinking, I just tend to keep drinking straight whiskey on these things. I guess it's pure, like my DSP, pure whiskey, right? Like Knob Creek. Last time I did some scotch or whiskey for you Scottish people. Kentucky bourbon. Last time I mixed it with New York City tap water. I've escaped to Long Island. Now I have bourbon and Long Island well water. That's my cocktail. Anyway, so I'll let's go to Marco.
Alrighty. I'm Marco. I'm having Highland Park, which you don't see because of the weird background thing. I'm doing DSP at Ableton, and I think I have a classical electrical engineer background and got my way into DSP from there. So I'm one of the DSP guys who likes to look at schematics from time to time. Don't know what else to say.
Oh, yeah, it's cool. Sean.
Hi, I'm Sean Costello. I'm the sound person at Valhalla DSP. I'm drinking this. I call this a Cara number 2. It's orange, lime, orange bitters, what's gin, and what's the other one? Oh, Cointreau. And I was an anthropology major.
Awesome. I did not know that.
And so I've just kind of like, as when you're saying I definitely learned outside of the standard academic stuff. But having said that, I also took some classes as an undergraduate at Karma, so I'm not exactly like full on pull myself up by my bootstraps. So I've had education, but just not a full on degree in this stuff. So
that kind of explains your propensity for being able to like look at old shit and and explain old reverb things.
Oh yeah, I was an archaeology major. I mean,
yeah.
Archaeology concentration in that. So within anthropology. So
yeah, you do DSP archaeology.
Totally.
we refer to that digging into old code as archaeology sometimes, trying to figure out what someone else.
Sometimes I call it forensics.
Yeah.
Well, I think there is a lot of forensics now with trying to figure out how old stuff worked because it's not necessarily documented in weird machine language. So
yeah.
You have to think about all the tools that were available, and yeah, totally.
I'll go to Peter next.
Oh, all right. I'm Peter McCullough. I work at Eventide. I've been there, I guess, 2 or 3 years now. 3 years? Does that sound right? Wow. So I'm the junior person here from Eventide. My background is in composition. I did my doctorate in that and was kind of in academia for a while, and then decided to make the jump. I've done interactive music for a good long while in the Max world. Kind of made some Max for Live plugins, and then kind of moved over to C++ and all of that. And at Eventide, I kind of do a variety of things. I work on plugins and H9 algorithms and just kind of miscellaneous stuff. So that's me. And I am drinking. I'm with you in spirit. I'm drinking a ginger beer.
Nice.
Because we have a 5-hour drive ahead of us tonight, and my wife informed me that I was not allowed to be drunk for it. So.
That makes sense for sure.
It's okay. Rosie.
Hey, Rossi. I'm
Rossi,
from,
sorry.
Yeah, no worries. Originally from Brazil, but currently living in Helsinki. I'm drinking Helsinki's on Fat Lizard Hop Road. Yeah, it's a hoppy pills, nice for a warm summer evening like today. And yeah, I do mostly kind of everything from product development to DSP on Miro DSP. And I currently lead the plugin and the audio research team. And I don't really do the nitty gritty DSP stuff. I mostly like fix stuff around or like that. This convolution is not working. Then I go and try to do some modern C++ to fix it. I think mostly things like this. Like I am very interested in analog modeling. I did a lot of stuff regarding that. Not so more anymore. Like I'm more in working more on Windows 7 32-bit installers problems and things like this. So
we know your pain.
Yeah, so I kind of like I started doing the DSP on Nero DSP, and then I end up like putting the whole plugin together and shipping it out and things like that.
Yes.
And yeah, it's really nice to be here among like so many great people of the audio world.
Dan.
Hi, I'm Dan. I did the Dan Gillespie. I did the electrical engineering DSP thing in undergrad and graduate school, and then worked at Eventide for a long time, and now I'm the chief janitor at Newfangled Audio, drinking Talisker. That's about it.
Yeah, I invite Dan on here because I kind of consider him the unofficial co-host. Newfangled is the unofficial co-host of this drunk DSP.
I hear the janitor shares an office with their CEO.
Yeah. It's a real equitable place.
Yeah, there's a lot of we believe in equality here.
Yeah. Charlotte.
Hi, I'm Charlotte Devage. I am drinking Kalila, which is a smoky Scotch whiskey, which is my favorite one.
Yum.
My background's in physics and acoustics. I work at the University of Edinburgh. I'm currently teaching mathematical computing. So I have a bit less time for working on DSP, but I still try to sort of convince my math students to do some audio stuff and physical modeling. And yeah, physical modeling was, well, still is, I guess, my main research interest. Yeah.
And Henrik.
Hey, so I'm Henrik. Hi. So I'm as Marco. I'm a software engineer at Ableton, mostly working on well, effects and instruments. Well, starting from the DSP up to well, the final UI implementation. So the whole device development chain. I do have some academic background on well DSP, but also some sorts of machine learning. So I did my grad studies at the UCAM in Paris, which was nice. So that kind of gave me a more or less holistic picture. But I don't have that classical master's in electrical engineering, but I did my grad studies. I don't have any kind of liquor or spirit. I just stay with a classic Pilsner. I didn't want it to go that strong, at least not while we're talking.
I feel a bit attacked.
You're the other doctor in the house, right? Here.
Well, we have a third one, which is Rob. He's just not with us at the moment.
Gotcha.
I think technically, but
Oh yeah. We have 3 doctors in the house in this particular virtual house here, right?
There you go.
Because Peter has a doctorate. Yes. Yeah.
Well,
And then there's the rest of us.
But...
DMA, right? Is it?
No,
No,
PhD.
it's a PhD. Okay. Yeah.
Actually, my graduation is in power distribution and generation. I have an electrical engineering degree, and my emphasis was electrical distribution and generator. So I basically had 5 years of my life spent studying how a power transmission line works.
Wow.
And that has been very useful to my job so far. That's
well, my first engineering job was actually working at a company that was designing a 345 kilovolt power generation plant, and I was running the 345 kilovolt three-phase lines that like went to the switching yard from the generators. And I knew nothing what I was doing, but that didn't stop them from letting me do it.
Well, didn't you tell me there are people at that company who didn't even know how to like take an integral that were like senior engineers?
I shouldn't put that company on blast on the internet, but
well, I'm not saying who they were.
it was the experience that made me run screaming from large engineering companies.
Yeah, I went to school, and most of my friends got hired by large defense contractors. And at the time, I was like, no way, I just want to play bass. That's what I did. I remember standing in line, and they were the guy, the head sort of teaching engineer was like, "Where'd you get a job? Where'd you get a job?" And everyone was like, you know, the usual suspects, Lockheed, Raytheon, yada yada. And I said, "I want to play bass," and he wrote unemployed. So I this group of people, I mean, there's a lot of virtual analog, which is always kind of a hot topic. There's definitely reverb, and algorithmic reverb, and then physical modeling reverb, and then there's definitely synthesis between Henrik, and then I know that Charlotte, you did like physical modeling synthesis, right?
Yeah.
So yeah, we could go a lot of ways with this. We'll probably get a lot of questions. James has been putting them up. A lot of people kind of want to know how to get into this. So it's like a question from YouTube already. When possible, could you please give some pointers on how to start in DSP if you're coming from a computer science background?
I would say the first thing is download JUCE and make a knob that controls a filter cutoff. And from then on, it's kind of a landslide. Then you start seeing, because, okay, I read the textbooks on recursive and FIR filters and that. Okay, but that didn't really make much sense until I made like a window with a knob that I could tweak it and it would change the sound. That not only made me really understand that, but also made me feel so excited about that I had to learn every little thing about it. So
that's a really good point. And I think it's like when I was doing stuff like maybe, 10, 12 years ago, I would just do GUI-less audio units and VSTs. And at this point in time, it's harder to do that than to just probably get a JUCE plugin up and running. I think you're right. Like get a plugin, maybe frequency, resonance, do the Chamberlain state variable filter. It's really easy code. It works. It sounds good.
Yeah. Like just put the minimum low pass filter together and make it move with a knob. Like that, if that doesn't hook you up on that, I don't know what will. Like, and from that is like landslide.
And I think that's the thing. Just like it's a stone soup thing. Start with something, and just do that, and then build from there. Like if you have a filter, try putting a delay line in there. If you have a delay line in there, put a feedback knob. If you have a filter and a feedback knob, it's like you're most of your way to interesting sounding echo, and then you can just keep building it up from there, but just iteratively. And my other thing is maybe it's not true for everyone, but give yourself time. This stuff takes a long while. You don't have to, just because it's like, it doesn't work coming out of the gate. It's like, just keep trying at it. It's like everyone's a beginner at this, and everyone started off not knowing what they were doing.
Yes.
No,
you guys,
go ahead.
How many of, we kind of said as much, but I think like at least 5 of us went to electrical engineering school, and I think that's usually a pretty consistent program, and in that way I learned like years worth of theory before writing any code.
I would have given so much to know that. Yeah, it's like if you're at a point where you can decide that you could do that, like you're
I don't know that it was best, because most of my electrical engineering experience was being told how to make like switching power converters and me trying to figure out in my own brain how any of this related to audio, and sitting through electrical engineering classes trying to figure out how any of this could relate at all to audio, and my professors had no idea because they don't care. So I think it's probably faster a different way, but it's hard for me to answer from like a practical, like, how do I get going in 6 months? Because I do feel like I had years of theoretical math before I personally started writing code.
I think
One.
oh, go ahead, Peter.
Oh, I was just going to say one resource, because I've kind of done this myself, just, not coming from a wishing now that I've had the engineering background, but one of the resources that really helped me was the ICST DSP series. There's 2 PDFs. They're both pretty long, maybe 100+ pages long, lots of really good pedagogical explanations of various synthesis algorithms, and, here's how to make band limited impulse trains. Here's how, various interpolation schemes works. The first part is synthesis and the second part is effects. There's also included C++ code with it. It's out of ICST Zurich, and it's a really great resource. I learned a lot from going through it. So I would also recommend that for the folks at home.
I didn't know about that one. That's awesome. I'd also recommend, like, probably Miller Puckett has the technology of electronic music, I think it is, but it's like based in pure data, but a lot of theory in there that's really good. More advanced is the publications out of Karma. There's a lot of stuff available for free there. It's really good. And then the DAFX book is great.
I have it open right here from something I was working on yesterday.
Nice. Second edition. Is that
second edition.
Yeah.
I have the first edition in the closet.
Who has my second edition?
One of the books that when I first started doing it sort of professionally, and it was a great resource.
Is that my second edition from Eventide, or is that your own?
No, I bought my own.
Oh yeah.
Stealing yours.
Someone has mine. I don't know who has mine. Someone who needs it. I've memorized the whole thing at this point, right?
Chapter 13.
The hard thing, I think computer science is a good place to start because you have a lot of the practical sort of like doodad, sort of hook it up widget knowledge, you can make a program, right? And that's often the harder thing for someone who's a pure electrical engineer. That was sort of my story, is it's like, I was just pure electrical engineer, and it was like having to catch up to the computer science part was the hard thing. Because I was gonna say that signal processing that you learn in electrical engineering school is all linear time invariant, and that's not very interesting musically. So if you want to be a music DSP engineer, you gotta have to learn how to break the right ways to break that, and kind of, I kind of liken it to like smoothing butter over toast. You gotta make things nice, and breaking.
Cold butter does not work.
Yeah, cold butter doesn't work. You gotta heat it up a little. Now, breaking those sort of classical rules that most of it came out of Bell Labs for speech stuff, is basically I feel like is 90-something% of my signal processing job is figuring out how to break those rules so I could make this stuff musical.
One thing that's nice about those rules, though, is that they still apply. I mean, you can get a good DSP. There's a couple of like DSP textbooks like Oppenheim and Schaefer and Rabiner and Gold that came out in 1975. They're still great.
It's kind of like jazz. You got to learn the old stuff so you know how to break it appropriately.
Yeah, exactly.
Yeah, Oppenheim is still a go-to reference for everything.
Which one?
The Oppenheim.
Oh yeah, the Oppenheim. Yeah.
And what about the Will Perkles book? I know it's kind of some people don't really like it, but they're so like easy, approachable for somebody that has never seen a Z transform in their life. Like, I think it's not the best code. It skips a little bit the theory here or there. But if you have never seen a Z transform, if you've never had heard about Laplace transform and Z transform in your life, I would say that the Will Perkles book is the most approachable one.
I think that his book on I have both of his books. The effects one is like, okay, that's pretty interesting, but the synthesis book is really pretty good because it's like it seems like a more gentle way of getting into zero delay feedback filters and all that. So
that's the book where I understood like the zero delay feedback solution, and he explains the anti-Hovolanen approach, and he explains the Vadin's approach. And he doesn't mention Stefano D'Angelo there, just by the way. And but anyway, so that's where I really got it. Like, I have read Vadim's book, I have read all of Wanti's thesis and all of Stefano's stuff, and it only really felt clear to me what was happening on Will Perkins' book, on that the blue one, the synthesis one.
Yeah, it seems like he really does a good job of making that digestible. Plus, I think there's a lot of code that comes with the book. I know of at least one company where it's like I saw they were updating a product with new filters. I'm like, oh, these are the filters from just straight out of the book. But
Yes.
like, but I'm kind of like, if they work, that's great. Like I shamelessly will just say, it's like, yeah, it's like, I just Andy Simper's state variable filters I used in a plugin. Thank you. It was great.
Yep.
Yeah.
Is there, so that was kind of the question I was trying to get at for, I guess, those of you who didn't do electrical engineering. Do you find reading other people's code, whether it's C++ or MATLAB, to be really helpful? Or do you find reading about like Will Perkins' description of the theory being more helpful?
I find his theory more description. He does a really good job at talking about like what order things can, because he has code, but he also has sort of pseudo code or just like, more difference equations. And for me, the difference equations are very useful.
Yeah.
Because I mean, I still haven't really got my head around the zero delay filter stuff, because it's like I do reverbs, which is like all the delay is fine.
All that zero delay stuff for me kind of hits home when it's an electrical engineering thing. It has to do with state space. Like, if you could think of any system in state space, and Marco will know, we call it, usually when we talk about analog modeling, we call it the K method.
Yes.
Yeah, right.
I'm a big fan. I'm big fan.
Yeah, I'm a big fan of that too. So sorry, Kurt, if you're listening. I like the K method. But like when you get into the state space, that's when it doesn't really matter, because you realize that every digital filter has an infinite number of structures. Because if you express the digital filter in state space, you can you have a system of matrices that on both sides of the equation, you could come up with a rotational matrix to transform and make any structure you want, right? So once you kind of realize that, that's why certain filters have better time varying properties. Certain filters have better quantization things than other filters. And it's, once you realize that, it's sort of like an open universe, right? And now, if you just implement the whole thing in state space, and it's a lot more expensive, well, then you generally have all the best of everything, right? But you just have a ton of states and more math. So
it depends how much more expensive nowadays. Like, you get Eigen, that it's like basically the default algebra library nowadays.
Yep.
The job they do with Cindy optimization, it's pretty amazing. And
yeah, we love Eigen.
Yeah,
it kind of
comes for free. So
yeah.
if you're not talking about any implicit system that has more than fourth order, I don't see a point why not implementing with matrices in Eigen. It will be like much better job than you're writing any TF2 or any structure that you might want to write. Like, and it might give you less headache with the math.
Rossi, have you figured out how to have it not kill your debug builds?
What Eigen not to kill your debug builds? It's because of the memory alignment stuff.
Yeah,
it's not just that. It's because of it's all the function calls. It's travel the stack,
and also the SSC optimizations only kick in when you pass in some certain optimization flags of CLang, I know. So what you could do is maybe try a debug build, but find out some loop unrolling flags and stuff like this, and put that together on the debug build. Maybe it doesn't kill that much.
For us, it just murders.
I've just given up running my products.
No, yeah. But yeah, I have been playing a lot with Cindy optimization, and I fell in love with the FDN structure, because I said, like, how much can you vectorize the FDN structure? And then I started having a different approach to it. How about building the FDN structure with metaprogramming, templated metaprogramming, so you can do like all your filters, all your delay lines, they will be like recursively inheriting themselves. So this way you get a branchless FDM structure, like just by using metaprogramming. So that's one of the things that has been like kind of keeping me up at night lately.
The things that keep us up at night.
So like
That's a good question.
CRRRRTP.
CRRRRTP.
CRRRR.
How bigger can you be your linker error? Like, how can you make your linker error a few thousand characters longer? Yeah, that's how I like
Man,
it.
we're deep in the acronyms now. So we've mentioned FDN, CRTP. So we might have to unroll this.
Yeah, let's unroll. Well, like, so, okay, FDN, the feedback delay network, which I guess Sean might be the best one to talk about it, or maybe Dan, but I know that they did fabulous work with that. I guess Russ too, like since Eventide is. And CRTP is the curiously recurring template pattern, which is a metaprogramming template pattern that allows you to do fabulous stuff with C++.
Can I make an admission, and a very embarrassing admission? I knew about and was using CRTP for years, and I thought curiously recurring meant that it like just kept coming up in people's code. And then I was, oh wait, no, because it's recursive. Oh, it's curiously recursive. Yeah, that was one of those things that it took me years for that to dawn on me.
They should have made it a recurrent acronym. That would have really kind of driven the point.
Yes, yeah. It would be, yeah, but who doesn't love templated inheritance and variadic templates? It's so pretty. Makes I just dropped
and easy to debug.
Code. Yeah, it's so easy to debug, so easy to read warnings with that. And I dropped like a big bomb of templated code lately, and the embedded guys just came at me like, dude, what kind of language is this? Like, are you sure this is C++? I said, oh, sorry guys. Then we had to tame down a little bit the stuff there, and then we kind of made it work.
That's so funny, because I realized, like, I'm sitting here, it's like templated. I like, because I came from, like, most of my programming I learned on the job while I was working at Analog Devices. So we didn't use C++ at all. So it's like, you know, and there's still a fear in the embedded world where it's like, you know, there's C++, but you don't want to use too much of that. So basically my use of C++ is C with classes. There's like, I really don't, you know, it's like I create objects that have, you know, functions and storage, and that's about it.
You use it for state.
Yeah. State and functions.
State and functions, yeah.
And most of those are inline.
This just reminds me, one other reference for people who are getting started, just for that earlier comment. Also, the ISO C++ FAQ is really a great reference, just general C++ programming reference, like just for learning best practices and things like that. Like, you know, for instance, the difference between inheritance of interface versus the inheritance of implementation, you know, that you really want to keep those two things separate. You know, and it has really good explanations for why you might want to do that. It's a nice resource if you're looking to learn C++ and you're coming from another language.
This sort of brings up an interesting thing. Like, how many of us here that make products are using C++? Right?
Yeah.
So, and in Charlotte, I was going to ask you.
I don't make products.
Yeah, you don't make products, but are they? But it seems like schools don't really teach C++. I mean, obviously their job isn't to teach you practical. Well, it's more about the ideas. So I imagine you guys are mostly in MATLAB especially in the math and physics departments. Right?
Not anymore since last year, Python.
Oh, sweet. Even that's better.
I know. I'm all for it.
Yeah. But like, you know, I think for students to make the leap from Python to C++, how do they typically do it?
They don't really in math.
Yeah, not in math, I guess.
Yeah, physics is the same. I learned, when I was doing my physics undergrad degree, I was taught C++. Very rudimentary C++, let's say, mostly C. But now everyone's just doing Python. It's much easier for, you know, you want to teach them how to solve physics problems, not to, you know, build a piece of software, or they don't really need to know all that. They just need to know how to use a tool, which is some programming language which is easy to use, easy to learn, to build some algorithms to use this or that numerical method.
How many of you guys use Python here?
Not really.
Not really.
I go back and forth. I usually write the first version of my algorithm in C++. It doesn't work. I can't figure out why. I put it to Python. I put some graphs in Jupyter or something like that. Then figure out what's going on, port the fix back to C++.
That sounds familiar.
And that's why we teach Python and not C++. All that overhead is just not there.
Question for the Python users. In Python, can you do the sort of stuff that you do in people have done in MATLAB, like graphing out images and stuff like that?
For sure, yeah.
Oh.
There's something
nice
called
libraries these days.
Unplot. Yeah. So there's this really cool project. So there's something called Project Jupyter, where it's like a IDE basically for Python, and it's great and it has a lot of good stuff. But they've recently added, so one of the big differences between Python and C++ is Python is interpreted. So instead of being, MATLAB is as well, instead of being compiled and then run, it gets sort of compiled as it gets run. So there's a new project, and it works well to write C++ in Jupyter using an interpreted C++ compiler. So you can take your C++ modules and run them in Jupyter, and it works really well. The unfortunate thing is that particular stack doesn't have a plotting library that I can find. There is one out there that's a project, and this would be, I don't know, for anybody who works doing DSP or audio DSP in Python or in C++ using Python, this would be a home run. If you could run your C++ and then plot the output of it, and then take that exact C++ and just run it in your plugin, that would be huge. But that's something that is missing. Like I said, there's a problem. There's a plugin called Xplot that's supposed to do it, but I can't get it to work, and I think a lot of other people can't get it. I don't think anyone can get it to work. So
Business opportunity for someone.
yeah, well,
we'll pay you a little bit of money.
I think this is something that the DSP community could get behind and push a little bit, because it could be big for any of us who are using those technologies.
Yeah, I broke my MATLAB addiction in full Python. I use PyCharm, but it lets me single step like MATLAB. And this came up last time. It doesn't index from 1, which I think is the absolute fucking worst thing about MATLAB.
Well, the possibility of overwriting keywords is also a bit ugly.
Yeah.
Calling variables if.
Python has its own bugaboos too. Like everything is passed by reference. It'd be confusing.
So are you all just using directly Python, or is anybody using Julia as well? Because that's what my team is typically using for prototyping and for debugging certain algorithmic problems.
No, I'm not. What's it called?
Julia.
Julia.
Yeah.
No.
It's quite similar, but it's way easier to handle. And so it also works with Jupyter notebooks, and you can just run it directly in the browser, and it's easy to share the code. And it's a much nicer language than Python itself.
Write this down.
Yeah, that's so nice.
That's one reason to do this.
Yeah, if you could post a link to that, that'd be great.
Yeah.
I think it's julialang.org.
What are the advantages, in your opinion?
Well, I find it's just faster. It's just like, well, Python comes with lots of overhead. You need NumPy and everything.
I remember when we
was just,
started,
like,
it was
way more
marketed.
convenient.
It was marketed as like MATLAB with the speed of C++, pretty much.
Okay.
In the scientific computing community, anyway. I know it, like, for people who try it, it seems to be not successful, but people adopt it. But there's not that many people, I think, just because it's a bit less widespread. Python is still everywhere.
Yeah, it's interesting.
There's also a free virtual analog library written in Julia by Martin Holters from Hamburg.
Huh.
Which has really nice syntax to describe circuits, like diode here, resistor there, capacitor there, and it spits out nice models.
But what does it speed up? Like state matrices or? I got you. You hooked me. Sorry.
Just turned into a Julia tutorial.
Yeah, because I built some time ago a K method JUCE module. It's still there, like somewhere, and I think it's on my GitHub or something like this. And my goal was to do this like procedural build of a circuit. So you just specify the components and the nodes, but of course I took some few design wrong decisions at the moment, and it didn't scale up. Like it couldn't handle bigger circuits with more than 10 capacitors. So then like having a solution like this that might speed up some nice matrices would be cool to try.
Yeah. Just drop the link.
Yeah, there's the link.
Yeah.
All right, cool. Thanks.
Cool. Oh, thanks.
We got a backup of questions here. Here's a less technical question. Is the audio plugin market flooded? I see, like yes and no.
I mean, here's how I look at it. It's like, I mean, I'm one of the no people. Maybe a yes should go first.
That was a Dan.
Yeah, okay. I think there's yeah, it's a very flooded market. I don't know how you could even argue with that. I find out about a new plugin developer every week that I've never heard of. Is that bad? No, I think it's good. I think it's good that there's a lot of competition. I think there are a lot of plugins that don't offer anything unique or individual or that's different from what other people are doing. But I understand too why there's a lot of people who want to do it. I want to do it. I think everyone here wants to do it. So I don't think it's bad. And I think something like JUCE makes it so that anyone who wants to do it can do it. It lowers the barrier to entry. So, but yeah, it's sort of a bad idea to try to start a business model doing the same thing everyone else is doing, no matter what that is.
And my...
Oh, sorry.
You go ahead.
I just wanted to say, even if there are many, let's say, redundant, very similar plugins, I think they often have a very different workflow. Maybe different people find them attractive, which is also good.
Yeah, I think workflow can definitely be a compelling differentiator. I think I used to tell like interns and stuff that came to Eventide that, you know, every musical instrument is a synthesizer connected to a user interface, like a guitar or a piano, or, you know, a harpsichord and a piano are different synthesizers with a similar user interface, but like a harp and a guitar are very similar synthesizers with really different user interfaces. And that makes a big difference in the music you can make with them. So I think that that's a very valid reason to differentiate your product. So I'm not trying to bag on anyone out there in particular. I just think it's hard to say there's not a lot of plugin manufacturers.
There's a ton.
I wouldn't say it's flooded. I would say there's a lot of bad beats, like too many bad beats, too many half-done plugins, like too many. Yeah, there's another plugin developer every month. Okay, but most of them, like, I don't see a future in the plugin. But of course, there is a market for a well-done plugin with a particular niche, with a proper market approach, with the proper aesthetics and market values. Of course, like you do a plugin that has a nice preset manager, that has a proper installer, that has a nice compatibility with the system, good CPU usage, and of course there's space for that. Of course, people tend to seem it's flooded because there's just so many, but most of them is like literally people just making their first plugin and putting them to sell on some e-commerce that they set up in a weekend. So yeah, I kind of disagree it's flooded.
What do you, Sean disagrees? I want to hear.
I think it's just because I do see it's like, because when I first was doing this, I was working in a vacuum. And then, but like once I released products, I started meeting people that use it. And I just noticed, like, look at their plugin folders. No one's throwing out their plugins. It's not like everyone's like, okay, I have the one delay plugin I work with. I mean, like if you read in sometimes people are like, what's the best blank plugin? Is it this one or this one? It's like, there is no real answer to that. It's all subjective, and it turns out that it's like saying like what's better, a hammer or a saw? It's like you need both, and you might need several hammers the more of a craftsman you become. It's like you have specific tools for specific things. So it's like what I find is like even though it's like the market is like the number of like people doing it is expanding, I think it's like I don't see that it's like I don't think it's necessarily a zero-sum environment in terms of like if someone's buying this, they're not also going to buy this. Now, I mean, I have no idea what the world is going to look like once everything opens up. I mean, like with the economy changing, I do think that you might see a huge change in how people buy stuff and stuff like that. I mean, and I'm just kind of like waiting to see what happens there. But it just seems like, like I've noticed that like, like I know that Dan, we're on the little super secret plugin developers group. And it's like, it's like all these people are doing these plugins, and it's like, they seem like, most of them seem like they're able to be doing it. And, I don't see anyone's like, I see like there's a lot of coexisting that can happen.
Yeah. It's funny that creativity doesn't seem to follow the scarcity model, does it? Like there's a lot of abundance that can be shared, is what I'm trying to say. When it comes to people buying creative products that are using it to make art, I mean, I feel like what we're selling is emotion, right?
Yeah. That's definitely true. I think like when we are successful, it inspires someone to write a song, right?
Yes. Yeah.
But I also think, I guess maybe I'm being too judgmental because I think there's a lot of products out there that they don't interest me at all. I don't see what they're bringing to the table. But I'm also very critical about that sort of thing. But I do worry that I think a lot of people are doing, like you said, my first plugin. I don't think that they shouldn't do it. I just think that if you're trying to make a business out of it, you should expect to be bringing something to the table that no one else is. And I think that's true for any business.
I think so. I mean, like, I think it's like, it's not a good business idea unless unless you don't have anything else that you should be doing. Like for me, it's like, look, this is my best of bad choices. It's like, I'm not doing this. I'm doing plugins because for whatever reason, I would be doing this for no money if, it's like I was doing C sound and just like doing unit generators and all that and got weirdly obsessed with it.
I feel your pain.
It's more of, I mean, if it's your calling, I think you're going to find a way to make it work. I just do. And like, cause you're going to have your own passion and individual thing. And hopefully you get good at it. And it's like, part of me is like, well, what if you're really passionate about it? You're not good at it. It's like, but you work long enough at it and you probably will get good at it. I mean, that's the whole thing. It's like, I'm glad that, by the time I released my first plugin, I'd been doing DSP for like 12 years. And most of it is in secret. And I'm probably happy that most of it you can't see.
Yeah. Well, you can't see the compiled code I wrote 12 years ago either.
Yeah.
I've seen some of it.
You can.
Yeah,
but everyone has to have those first steps too. I mean, that's the only way you make your mistakes, you learn from them. Hopefully most people don't find them later, and and then you keep going.
I know, like there's a reverb I did in '99 that people like say, oh yeah, Sean Costello did this in '99. I'm kind of like, yeah, I know, I did that, but it's not that good. I was young. Well, I wasn't even young. I was like 29. It's just kind of embarrassing.
But it depends. Most people think like having a killer DSP idea, having a killer DSP and a nice interface, like, okay, now I have my plugin. You can click on it and you twist the knobs and it changes the sound. Like, no, this is 30% of the way. Like, okay,
doesn't work in 80 DAWs.
Yeah.
Yeah, like the first thing. Okay, so sometimes I see like some amazing idea plugins, they sound killer. But I said, dude, where's the support here? Like, I don't feel safe that this will work on my laptop if I'm doing a live presentation. Like, that is I think this is where most of the value of the plugin is. It's not on how dope it looks or how if it does the latest famous sound that some And it's not that. It's like, okay, this product installs clean or with any antivirus that you might have installed. It installs clean and it disinstalls clean. It has a proper preset folder. It saves the settings when you open again. It works on any DAW. It corrects the latency correctly. It has a proper preset management system. It has a proper file management system. This kind of stuff. Like, we think that the users don't see that, but the market tells us as a whole that this is the most valuable stuff. And sometimes people think, I have this killer DSP, this nice interface, I have a plugin. No, you have a nice idea for a plugin.
Yeah, it's like, is your e-commerce work? I mean, like, when I first started, it's like, I didn't have e-commerce. It's like, oh, I like send out orders via email. And so, no, literally, and like, so for the first 4 years I worked at Valhalla, in that time, I took 6 days off total, like 6, including weekends. It's like, I was like carrying my laptop on us with camping trips. I was like parked outside of a Burger King trying to surf off the Wi-Fi signal so I could fill orders. And I still had people mad at me. It's like, I ordered 15 minutes ago. Where's my order? It's like, I'm asleep. Or it's like, how important like e-commerce is, how important a good installer, how important customer support is, all that sort of stuff. That it's so not sexy and it's so important.
Exactly. So that's why I don't see that it's flooded. That's the reason.
I'm curious, do you see a lot of students who are thinking about making plugins? Is that something that you're seeing a lot of people want to do? Charlotte?
Yes, well, yes, the acoustics and audio students, a lot of them do. I think in the master's degree in Edinburgh, we've started last year a new course in audio programming. For I think the past, say, 3-4 years, that seems to have been an explicit demand from the students, because we taught them MATLAB, and they go on the market basically looking for audio DSP jobs, and everyone's asking, do you know C++? So yeah, I'm not sure if it's JUCE they're teaching them, but yeah, more and more of them do want to work with audio DSP, like, yeah, making plugins basically.
And that does bring up, I don't know, it's like, I mean, I've worked with JUCE a lot. I think it's amazing. I still think that there's a need for like a really solid example plugin. Like, this is what a professional plugin should look like. As an, like, just something that's part of the JUCE distribution is like, this has real world value parameters. It can compile in all these formats. It does, has a preset manager and all that. Because I think that would really go a long way towards like something that could be taught in classrooms. Where it's like, you put your DSP code here.
Yeah. You
put your, like, here's your preset stuff. And then, now, like, and that also would kind of like, there's still, even though we talk about how much easier JUCE makes stuff, there's still a ton that has to be done as far as like, how do you copy protect it? Do you need to copy protect it? How much copy protection should there be? All that sort of stuff that's like, there is still a big hill to climb that doesn't necessarily reflect like, your brilliant DSP idea or something like that. And
it seems like it's very specialized software engineering teaching. It's not, it's not what we teach, for example. We teach, acoustics, audio, DSP. Yeah, I agree. Like, that's a very, very small part of any job that they'll have in the end.
And it's something that's like, it's a very specific thing. And it's like, but there's probably like, if you approach it from like just looking at a class, there's almost too much to learn in this specific thing. It's like, it'd be nice if there's a more complete tutorial where it's like, because I know that Will Perkle has his Rack AFX class. It'd be nice to have a JUCE class. It's just like, here, put your code in here. Code goes here. You've got your GUI working, and you can work from there.
Well, then there gets into like GUI design and
user experience.
A lot of weird specialities that you have to pick up along the way.
I mean, the truth is, a lot of us just like, we farm a lot of stuff out. Like, we pay iLock to do our copy protection. Like, currently we're working on new plugins, and we've hired a third-party design firm, like, to, basically help us with some of our really specific design elements, that type of thing, right? Now, a couple of the smaller guys, I know, like Sean and Dan, you guys are running the whole thing, right, on your own.
Well, even then, I farm out the e-commerce, and like the iLock does the copy protection, and Eventide does the e-commerce stuff. So
Yeah, that's right.
those
Yeah.
are two things that Sean has to worry about that I don't.
And then Kristen, does like the visual side of thing. Does like we call her now Vision, because it's like also just kind of like corporate long term. She's the one that's, finding the web developers, finding our marketing people, because we don't have those people internally. So it's like, there is like, it's not one person, it's two people. And then Dawn Gunn is doing our support for us part-time. It's like that, which is like, I would not be able to do all this if I was still doing support now. I would not be able to do this if I had to come up with all the graphic design and the web design and, just the whole sort of like, there is more than one person can do, but you can certainly start out with one person doing it.
I just wanted to say on the authorization. Oh,
go ahead.
Go ahead.
I was going to say really quick on the authorization front. I imagine that may change in the future. This is purely speculative on my part, but just with the recent acquisition of JUCE by Pace.
Yeah, I do not know what's
to
going to
reason
happen.
that they would probably make that process easier.
Well, making there's a difference between making a process easier and process necessary. And like, plugin developers, we all know that about like the process that it becomes necessary because we all deal with Apple.
Yes.
And like, we've all had like stuff was like jumping through the hoops because Apple has tightened up access to their operating system. And it's been a pain. It's also probably something that's like, long term, it's going to be a very good thing as far as like, once you figure it out, then it's actually a pretty good thing, but then it's like, but yeah, it's like, it's one of those things that like, if Pace could come up with an easier copy protection, it might be really good for people to use, but we'll see how that goes.
Well, I would
okay.
just go out and say I'm relieved that with the acquisition of JUCE, so I don't know, I won't put anyone on the wall, but I'm very relieved that it's under a company that is truly interested on making plugins, because Pace wants people to buy plugins.
Yeah.
So their true interest is to give a tool to people who make plugins.
And as far as plugin developers go, they're a neutral party. They don't have a stake in any particular plugin format or anything.
Exactly.
Yeah.
And they've made stuff like
AI
signing easier. It's like definitely like in my experience working with them, the process is much easier than it was, say, in 2012. So.
Yeah. Well, that's what I see. Like, I'm relieved that a company that is truly interested on evolving the plugin, the state of the art of plugins now, it's actually with control of JUCE. And I'm not saying anything about Broly. It's just that JUCE didn't seem aligned with their true purpose, which was like offering creative tools and stuff. JUCE was a tool for them, so it didn't have to be part of the company. I guess it wasn't that aligned as it is with Pace, I guess.
I'm gonna pull this back out. So we meandered into business talk, huh?
Yeah.
Pretty much.
Always exciting for the folks at home.
Yeah, drunk. We're not drunk audio business. I'm gonna pull it back to drunk DSP. So there's another question here. What's the most efficient way to write a smoothly varying random LFO? Not slewed, sample, and hold, but naturally wandering.
Perlin noise is pretty nice for that.
What is it?
Perlin noise is pretty nice for that.
Mm-hmm.
But I mean, here's the question: is like, what do you use to make up Perlin noise? Like, I know I use several, like, random oscillators at different frequencies, but what sort of like, I guess they're asking what's a good random oscillator to do with that. Like, I used to use the classic like Rand I that was like written by Max Matthews back in 1969, but there's definitely better ways now.
Yeah, I think it also depends on what you're modulating too. For modulating amplitude, like a bipolar Rand I can actually be really interesting, especially if you're modulating a bunch of sources with them. For a delay line, it's terrible because you've got random speed changes and it's no good. So I really think it depends on like, well, what are you trying to do?
I think I used some cosine interpolated noise, some function, something or other, but or maybe a quadrat. Or it's like cubic. That's right. Both.
Yeah, I think so Eventide for a long time was on fixed point processors, right? And so that's a whole different ball game, right? Like you guys are all making plugins, like. So I deal with hardware and software, and it's increasingly more like software now. But Dan and I, we've been through the gamut with the Motorola 56K, and having to deal with fixed point DSP.
Future of processors?
Yes, it's coming back.
It's coming back. Fixed point's coming back.
Oh no, but no, I'm just as a question. It's like it'd be interesting, like talking about so many of this stuff started on 56K. That was the platform.
That was
And now it's like, I mean, is there still a room for like dedicated DSPs, like like for example, like the Sharks and Blackfins, and like or is it going more towards either like small arms like the STM stuff or larger arms like what you find in the cell phone?
I mean, we're moving all to ARMs. I mean, I would expect if you're really heavy into machine learning or stuff like Charlotte that you guys do, like finite difference schemes. You guys are mostly on GPUs. I remember Stefan was.
Depends what for, but for big rooms and 2D things, yeah.
Yeah. I wonder if there's any like machine learning specific neural network type processors or something.
There are some.
Yeah.
Yeah, I've never used one.
Yeah, I mean, I don't know.
Has NVIDIA not released a whole range of GPUs for?
Yeah, they do GPUs for that, but then there are also even more like experimental processors that are used in the military for specifically. It's like an ASIC basically for solving either like Bayesian inference or other sort of specific neural network or those kind of problems.
I know Boss spins their own ASICs, and Boss is able to do some really interesting things with their synthesis pedals, right? And my sort of naive hypothesis is that they just have some heavy parallelization going because they can spin their own ASICs, their own chips, right? Like they're doing lots of parallel filtering and stuff, right? I would think. Right? Who knows?
I kind of wonder if some of the Boss stuff is like much more old school DSP. Like if you look at like a lot of pedals nowadays use the spin semiconductor FV1, and the architecture of that is much closer to what Alesis used, and it looks very similar to kind of like the architecture that was used in old Lexicon hardware. It's like it's very like just sample at a time. You have one memory buffer that gets incremented through. So I mean, in some ways it's like I don't know if it is parallel or if it's just like really old school stuff.
But if you could do 1,000 filters at one time, that's.
I don't think Boss pedals need to do 1,000 filters at once.
Well, when I listen to their synthesis stuff, to me, what it sounds like is it's like a low latency filter bank type of like if you play your guitar through an SY300 or whatever that synthesis pedal is, right? Like which I've played through it, or the cheaper one, the littler one, the SY1 or something. You get this polyphonic synth that has almost no latency, which to me suggests a filter bank.
Does it have a chirp?
I haven't tested it. That's a good point. I know we've tested the EHX stuff, and that has kind of a chirp to it.
Yeah, which kind of says like some sort of like basically multi-rate filter bank sort of thing going.
Yeah.
As opposed to like FFT, it's something.
Yeah. And the problem, we use a lot of general purpose arms and stuff, right? And you can get SIMD, right? But the thing I missed about the 56K, even though it was a pain in the ass, was you got like MIMD, right? Multiple instruction, multiple data processing.
Oh, I hate that. No, I mean I do, because it's like at one point I was programming stuff for the Texas Instruments processor that they ended up using for HDX at Pro Tools. And that's like basically like a very large instruction word. You can do 8 different things at once, but it's really hard to pipeline more than 2 things at once.
Yeah, that thing was hard. Yeah, I agree.
That thing was really hard because it had slow memory performance too.
Yeah.
So it was like you could do 3 things at once, but this one instruction is going to take 30 cycles to return.
and I remember it's like, oh, you can do all these things like very fast in C code. Oh, except for you can't do like fast memory lookup with that. Yeah. It's like, okay, I was doing, like reverbs are about almost all memory lookup. So it's like, oh, okay.
HGX is really bad for reverb people.
It is. It's tough.
Yeah, without a doubt.
56K was really a bear to program in, but the other nice thing I had was single instruction memory lookup.
Yeah.
So it, algorithms that were written on that and then we ported to either ARM or x86 ran like 10 times faster on the x86. Or
It's
on
not,
the, I'm sorry,
yeah.
Motorola.
On the Motorola.
Yeah, it's not apples and apples. It was like 125 megahertz Motorola chip from like basically like 1990 something. It's equivalent to like a 500 megahertz ARM.
Yeah, and there's like this spin semiconductor part is like a 6 or 12 megahertz chip, but you can still do nice reverbs in it because it's just like it does 128 instructions per sample, but they're very efficient. Like you could do an all-pass delay in 2 instructions.
Yeah.
That's when DSPs were DSPs.
And you don't have to increment the memory. That all just happens for you. So
yeah,
I would expect, to answer the original question, I would expect things both in laptops and everything to be converging towards ARM in the next decade.
Yeah.
Yeah, are we going to
everything we think about?
Plugin developers, DAW developers, are we going to have ARM ready things for the Mac? You think?
Oh yeah, I mean,
yeah, for
I
sure.
thought something was almost pre-announced that it's going to be like next year.
Well, I had like my little conspiracy theories. I mean, I'm sure they've had it running on the like Mac OS have been running on the ARM for ages. Part of me always wondered, is this something that's really going to happen, or is this something that they can use to negotiate for better Intel processor prices? But at this point, I think I better get ready to port to ARM.
That's why you should use Eigen.
Yes.
I want to talk with you about Eigen after this because I've been devoting most of my last year to programming in Eigen, and I got bit real hard putting it to Windows.
Yes, that's the issue.
And by
I actually solved that problem, so we should talk afterwards, man.
And by proxy, I got bit real hard.
Yeah, because I gave you some code.
Because you gave me some code, yeah. So question from Chris Santoro. He was on the last one. What's your perspective on non-analog modeling effects like DFT-based mangling and other interesting things that are impossible in analog?
The only interesting effects.
I can repeat the question.
I think pure digital is a great way to go. I mean, it's like, because it's like you can sit there and model a perfect analog filter, but if you go over to like a clean IIR filter and you have 20 of them or more, it's like there's so many things that you can do in that way. I think there's like the world of just like not worrying about analog is great. I mean, having said that, I love the analog stuff. I got a lot of analog sitting behind me, so I think DFT, FFT stuff is fantastic.
Most of our like at Eventide, our first foray into this was sort of the fission thing, the structural split stuff, right? And that's all FFT based processing. There's no really sort of analog thing there at all, thinking going on at all. So we're not mangling much with it. We're trying to like preserve what your perception of what you think is the difference between tonal and transient, but I have my own personal manglings going on there. They're not like ready for anyone to give me money for.
And it's true. I mean, like a lot of like kind of elementary FFT mangling ends up sounding like low bitrate MP3. So it's like there definitely has to be some like finesse going on. So it's not just like, treating things on a band by band basis. But I and that's about as much as I know is that you can't do that. I'm not going to speak to what you can do. So
have anyone tried anything with Gabor wavelets, like constant Q Gabor wavelets? Like that was pretty much like the most elegant musical notation preserved wavelet transfer I've ever seen.
Yeah,
it was not invertible for a while, but someone figured it out, right?
Now it is. Yeah, I just I looked at the paper like at the thesis last year. I think now you can invert it back, so you can transpose it and move it back to audio domain.
A lot of the problems with that stuff has to do with latency.
Yeah.
And that's only a problem in as much as it's a problem, but for a lot of real-time audio effects, that tends to be a problem. But
we couldn't put it in a guitar pedal, but we could put it in a plugin.
well, it's tough. I mean, a lot of latency.
and I wonder how much of that, like for something like Melodyne, it's like I wonder if there is some technology out there in the commercial world that goes beyond what's been published. Like I don't know. It's like, you know, it's like, because I mean I've heard some stuff. It's like, you know, for example, it's like, you know, it's like, are people using wavelets or some sort of like, you know, multi-rate filter banks to do stuff that, and they're just kind of keeping it as trade secrets?
I'm sure that they are, for sure. I did a thing in grad school using like basis learning, like learning of bases for a, you know, the FFT is one sort of dictionary transformation, but you can learn any sort of other basis to do transformations, like learning the bases based on trying to solve particular problems. And that was a really interesting project. It didn't go very far, but I think there's a lot that could be done there if someone was interested.
Yeah, I mean, the FFT is interesting because it's an orthogonal basis function, right? So it uniquely defines each of its elements. But if you can have basis functions that are overdetermined, right? Right, and that could be interesting, right? Like a Esprit, whatever comes to mind, right? Like that type of stuff.
Yeah, there's a lot of interest. That's something that's just from a mathematical perspective is really interesting, and there's like literally an infinite number of options there. There's, what's it called? Method of frames is a good one.
Yeah, that was a theme of DAFX one year. It was the frame. I think it was at Edinburgh. Was it the Czech Republic one?
I think it was in the in Brno in Czech Republic.
Yeah, the frame theory was. I'm still like, I keep like in the free time I have between like my life and children and stuff, I keep going like, I gotta nail down that frame theory thing, man. I gotta get to that frame theory thing, and that was like 5 years ago at this point.
Yeah, I think there's like a pretty much infinite number of interesting ways we could manipulate audio signals. So I'm not worried. Actually, that's why I said earlier that I think that the market is flooded, because I think the market is flooded with things that do the same thing, right?
But there's also an even more infinite way of uninterestingly audio signal.
Very true.
Yeah, of course.
I'm really wondering why. Sorry. Just wondering why we people are obsessed with recreating analog gear instead of trying new things. I think really a majority of plugins out there is just these 36 recreation tube screamer circuit trying something novel. I don't know where this creating odd stuff comes from. No idea.
But we can't forget that the audio world has been like. Sorry. Sorry, I didn't mean to cut you. I thought it was.
It was a network thing.
All good. Feel free to answer, Rusty.
Yeah, no, sorry. It's just that the audio world has been like this, like since it is the audio world. Like the Moog filters are still on shelf with a high price tag, and there are still many manufacturers setting up their business making Moog filters, ladder filters, and there's gonna be more in the future. Like, and with the same thing with the tube screamer, with any other pedal that you think of, any other like the fuzz face or whatever. Like, there's many recreations of that. There's gonna be more in the future. There are many recreations of all the classic synthesizers. I guess it's just normal that we'll have many recreations of the same plugins too. Like, it's an audio market thing. Like, everybody does its own with a different label, and people love it. I guess it's
most bars will sell you an old fashioned.
Yeah.
but I mean, but for me, it's like saying, well, you know, like there's too much wine out there. Everyone has very specific, weird little taste in wine. It's like for me, it's like I literally am holding up 3 different big muffs, and for me, like these all do something. Well, I'm holding up 2 because. Okay, now I'm holding up 3. It's like these all do very different things. They have very different nuances for me but for most people it'd be like that all sounds like a fuzz.
But it's still different, right? Because there are mods of an original thing and they have some novelty, but there are, I don't know, at least 20 pedals which 20 plugins try to exactly sound like the 78 tube with the famous IC XYZ blah blah, and that's a bit odd maybe.
But I mean the point is like it's just like anything else. It's like there's all these different clones of the same thing, and you could argue none of them succeed. But because none of them succeed, they all have their differences. It's like, I've heard people say, why don't you, like, oh, it'd be nice if you do your version of that. And I'm just like, I did my version of that. I absolutely have my version of that. And the fact that you don't think it sounds like that means I goofed up, but also means, well, I guess I brought my own thing to it.
Yeah, and it's true.
By
If you
accident.
ask customers what they want, 9 times out of 10, they ask you to make something that already exists in some other form, right?
Or something that exists that is unobtainium. Like there's definitely a lot of people have said, "Oh, I want to hear an Ursa Major space station." It's like so few people have actually experienced an Ursa Major space station. I don't even know how many recordings they're on. So it's the idea of it.
Didn't Eventide used to have an Ursa Major space station?
Yeah,
Plug-in, right?
like licensed from Ursa Major, I believe.
Yeah.
Like I think Chris Moore helped you with it, but then it's like I think he rest in peace. So I don't know where that is, but it'd be great if you guys brought it up again if you can.
Chris Moore had done a little. It was weird. It was a funny little thing. It was like a little box with a 56K in it and like headphone in and out, but it was small. It was like it was the size of a guitar pedal, but then really flat.
Yeah, it's like the Lark, but if the Lark actually did the signal processing.
Exactly. And then I think Tony at Eventide or someone licensed it and sold it as a TDM plugin because it ran on the 56K, but I don't know. I don't think it was ever ported to C++. I don't know anything about the legalities of it all. Chris Moore
it's probably because I got so sick of 56K. I just didn't want to do it anymore. I'm done.
But that'd be an interesting thing. Is like because you guys you have the graphic assets for it. You have like that stuff. It'd be an interesting thing to do because I also know it's like you definitely like Eventide had plugins out of various things, and then they've done newer versions where it seems like you've applied more analog modeling, more precise modeling of the fixed point digital stuff that was going on. So it's like even though it's the same thing, it's like it still sounds more like the original hardware than maybe the first round of the plugins did.
Yeah, Dan did a lot of that work for the 910s and 949s. We're into analog modeling of our own stuff. We tend to sort of philosophically like not get into the game of analog modeling other people's stuff. But I guess we reserve that right. We're 50 years old almost. So.
A legend of itself already. So.
Yeah.
I mean, I think also with these analog models, I think it's also like, I feel like there's also an opportunity to extend the model. It's like it's an interesting parameter space, right? But it's really only one point in that space, or kind of a narrow cluster. And so I think it's like there's something that's compelling about that space, but I think it's also like a really good opportunity to like look at things that are kind of around and adjacent to that, and like what are some ways that we can kind of extend it? Is there like something interesting we could add with like an envelope follower or any other sort of like more playable kind of aspect to it? Are there just different ways that we can shape things, add interesting feedback paths? Like I feel like if you don't do that, it's kind of a missed opportunity. That's just maybe too strong of a statement, but I don't know. Just making it sound exactly like the original is like, well, yep, there it is.
No, I don't think that's too strong at all. I think you're totally right. That's the interesting thing, because if you can make it sound exactly like the original, then it's like, all right, cool. What else can I do that's better?
I will say too, from experience, making it sound exactly like the original is so hard. It's so much work.
Yes.
But it's also, I think it's an interesting learning thing to try to make something sound like something else. Because it's like, for me, it's like I can invent stuff all day and that's fun. But like where I've actually tried to like recreate something else, it's like, it just, what it is like, it's not about like at the end if you succeed. It's just like, well, at that point, I didn't succeed, but then those become ideas that you have. And it's like, whether or not, is that exactly how it works? It's like, no, but it is a way to work. And then I've even seen, like, even in the analog domain, like for example, behind me, I've got this this
Sweet.
Moog, like
Well,
You
grandmother.
have an Eclipse back there?
oh yeah, I got
Nice. There you go.
I got
He's got all kinds of he blogs about Eventide reverbs all the time.
I didn't know you had an Eclipse.
Yeah, I got an Eclipse. I got an Ultra Harmonizer. I got the H3000. I need to like plug these things in. I don't. They're not hooked up right now.
You got an MS-20 back there, yeah.
Oh yeah, but for example, like the grandmother is something where it's like this came out after Moog had done the like the big reissues of their modular gear, where they're actually hand wiring the original Moog modulars and all that, and people were like, "Why are you doing this? Who's going to be able to buy a $35,000 modular synth?" And then a few years later, they come out with this thing that's sold for like $899, and it's surface mount, but it's based on most of those old modular circuits. And part of me wonders, it's like, it sounds like that, but it's almost like they had to go back and like kind of learn what something did in the past, and more so than they thought they understood it, in order to know how to make that kind of go forward with that sort of stuff. Because it sounds very different than like say like the sub fattiers or whatever. It's like, it sounds very different than other modern Moogs. So it's really interesting, just like by going back and learning that, it seems like then you can extend upon that, but you might need to go through that exercise of going back and really trying to recreate something as much as you can to learn that stuff.
Yeah, that's a solid point.
Fully agree.
Yeah. I was going to say, I think that's something that we've been encountering with some of like our recent stop box effects, you know, with like both Armadillo and Tricera, of course, are kind of based on these models of like kind of classic effects, you know, like harmonic tremolo and trichorus, and then kind of going back and looking at some models, some exemplars of those, and then trying to figure out, okay, what is it that people like about this, and what's kind of the interesting space here, and then what's kind of around that space, and how can we stretch that model? Yeah, I think there's definitely value in trying to get it to you know, learning how to make like what is good about this thing. What is it? Is like, is there a subtle boost here in this part of the spectrum that actually adds this color to the sound that you might not, you know, kind of like expect? You know, like what are the discontinuities in it? You want to know those things, but just doing that, I sometimes feel is maybe not as rewarding.
I totally get that, but I think there's something about like, oh, I wouldn't do, like, there's like, I definitely felt when I was younger, I mean, a young man of 40, it's like, oh, I know what I'm doing more than this sort of old stuff. And there's something to be exercised about. Really try to do what they're doing here, whether or not you think it's right. It's like, do that, because then it's like, I mean, like, it's like, because I'm really like, because I was an anthropology major, it's like subjectivity is so huge for me. There is no right. I mean, there's things that are, I mean, like, other than like, there are some basic moral things, I think. It's like, I mean, like, it's weird. It's like, I mean, sometimes I about, oh, like, I do postmodern plugins. It's like, oh, this has a very different meaning in 2017 Europe that was very different than was going on early 90s theory and stuff like that. So it's like, you know, there are moral constructs, but as far as like aesthetics, it's like, you know, it's not really, there's no one platonic solution. And there's all sorts of things that if you learn someone else's solution, it's an interesting learning exercise. But I also think to the same point, it's like people that like only recreate exactly what was in the past. And like, this is like, you know, at this point in 1979, God's finger came down and touched the world, and that's why this is the best reverb ever. It's like, no, not necessarily, but it's worth learning about that sort of stuff. But still, you have to have your own like philosophical stance on stuff as well.
There's a similar process, I think, in the way we do physical modeling synthesis, where we try to sort of make virtual musical instruments, basically, by just simulating them physically. So, you know, we spend a lot of time trying to really make a really nice, accurate physical simulation, and, you know, make a virtual instrument that sounds like the real thing. And then we give it to musicians, and they're like, I don't want that. I want the 50-meter long trumpet, please. Because it's just changing a number. But they don't care about doing something that's realistic, that sounds nice. I can try to make like a really nice sounding like vibrato with like all the bells and whistles on my boat string. They don't care. They just want like the really screechy, horrible stuff because that's more interesting. But I think if we didn't spend so much time nailing what, the model, trying to represent that exactly as what we already know, like the physical instrument, then whatever we could do with it later wouldn't sound as good, like wouldn't have this kind of quality. Like
Fully.
the crazy stuff sounds good and sounds almost kind of natural because you spend so much time trying to nail the original thing.
Yeah, I agree 100%. And to be honest, my sort of crusade against analog modeling is a caricature. And it is a caricature because there's so many, I think there's this perception in the market that analog means good. And I've had, for instance, my main product at the moment is a mastering look ahead limiter, right? That is modeled on the ear and some like perceptual characteristics. And I've had several people ask me for an analog version because it will sound better. And it literally couldn't be made in analog. And I don't even think, I don't know, I don't want to put on blast anyone who said that. I think it's a valid, I don't want to say that it's not a valid request. I think half the time people who say analog mean hardware. And I think half the time they think hardware will sound better. And I think half the time hardware does sound better only because it costs so much to make and it takes so much time to build that you sort of, as a DSP engineer, you have to put a lot of effort into making sure it sounds good. But it's, to some extent, I want to break that mold of the customers who think that just because something says it's analog means it's good. There's a lot of bad sounding analog stuff. There's a lot of things that are trivial to do digitally that would sound a million times better than, something that you would actually try very hard to do analogically. Like a mixer, for instance, like a cheap analog mixer has usually a lot of high-end roll-off and a lot of noise, whereas in digital, it's 3 lines of code, So I do want to shake people up a little bit, but it's obviously important to understand what went before us. And I think there's actually a lot of validity to analog as a concept as well, because fundamentally it's called the analog because it's an analogy to the physical world. And a lot of the early analog circuits were mostly trying to solve the same differential equations that happen physically. So they're either acoustic circuits or physical vibrations or things like that. So those, in the linear sense, for the linear versions of those things, those equations are the same fundamental differential equations. And that means that they kind of do tend to sound a lot more natural than some other random thing might.
I got so you guys keep going. One of the problems with drinking a diuretic is
Okay.
I gotta run. So I'm gonna ask one more question. You guys talk without me, and then I'll be back, and then we'll wrap up. From Facebook, are there new applications of sound that are exciting for you as plugin creators and a physical modeling researcher? So with that, go.
No.
No, all right. And then I'll be back in a few minutes.
It depends. There's of course, if we just go into medical research and stuff like that, like you can get very, very far away with it. But I would say more in the musical industry. There's a lot of stuff like nowadays. People have been noticing how crappy the feedback cancellation is on conferencing software. And that it's a quite interesting DSP field, non-linear feedback canceling. There's many PhD theses on that, and it's a problem that's still not solved. I don't know. There's the corporate world also needs something.
I think it's funny that we're all sound people and we're all wearing headphones.
I'm not, because I just realized that the laptop echo cancellation works a million times better if I use the laptop speakers.
Yeah, and it depends. When I'm using my monitors, then it works crap. When I'm using the laptop speakers, then it works nice. I guess it doesn't adapt fast enough. I don't know.
I think Apple just hires a bunch of acousticians and TSP folk to solve this particular problem, and they spend a lot more time trying to solve this problem than most of us do trying to solve analog modeling problems or anything else. I think it's a big field.
I mean, I do think one thing that's been interesting about the pandemic, and I think the public's general awareness of latency is heightened. And I've had any number of musical folks asking me like, hey, is there any way we can perform live? And I'm like, no, there's no way you can do it. You know, it will sound good for one person, you know, and the rest will be horribly out of sync. And it probably won't sound good because everyone will be horribly out of sync. So, you know, it's just like, but everyone's convinced it should be an easy problem to solve, you know.
If you could quantize the latency to like 4-bar loops or something.
Well, so that's actually what NinJam does. And
Exactly.
yeah. So there are, I mean, if you're working with a particular kind of loop-based style of music, sure. If you're not, then well, you know. Yeah, so I think that's actually an area maybe that we'll also see further research in, is actually lower latency and collaborative tools for musicians, because, well, this may not be the last time.
It's interesting.
Yeah.
I know just over the years, a lot of people who've given demos at NAMM or worked on this problem, and it's sort of been a solution without a home. And now I kind of wonder where, I think a lot of people have tried it. I don't know how successful they've been, but I know that there have been some efforts to allow people to jam in real time over the internet.
Yeah, for sure. Problem is still a significant contribution to the overall delay is just the latency of the physical cable, and unless we're limited to transmit signals in light speed, this won't change.
Yeah, there's a fascinating. I saw something recently talked about how there was some stock exchange that actually had like cables of a specific length to delay stuff, so that like for kind of like so that there wasn't some unequal like you know advantage, but then, you know, so they just like their delay line was just basically a whole bunch of coax, you know, coiled up.
Yeah, I think I saw that. It was a documentary recently, right? I think I saw that too.
Well, yeah, it's hard for me to think like of DSP outside audio. It just doesn't make sense to me, I guess.
There's, you know,
of course, telecom and
a lot of people who did DSP in the 90s and stuff went into talking about coiled up cables that went into high frequency trading and trying to solve those sort of low latency problems. I did a tiny bit of that at one point, but I think, you know, machine learning is another big one. Machine learning's getting big now, and I think there's a lot of overlap with signal processing. Both applications of machine learning to signal processing and the ability for C++ signal processing engineers to jump towards doing applications of machine learning, because
of course I guess so far I have seen a lot of results towards modeling on with machine learning, especially like on those implicit nonlinear systems that you have to do like some interactive solving. So there has been popping up like many creative ways of dealing with that. Also on the field of like transport, how to mix different kinds of sounds into like also the music creation. But still, there's one kind of algorithm that I don't see the machine learning coming into it, which is like kind of the creative effects. Like you have some kind of glitch matrix plugin like that. I guess maybe you could use a little bit of machine learning inside there. I don't know, but in this kind of stuff, that these interactive kind of plugins, I don't see many fields. But in the modeling, it has been like giving some great results.
Machine learning helps a lot when you're looking for either a right answer or you're trying to solve the best among a number of answers. So
yep.
I think in a purely like left brain creative sense, you have to really kind of train the model with some sort of, you need to know what the right answer is going to be. That needs to exist.
Yeah, and it can't especially do what Sean said before. So you can recreate a thing using some kind of AI machinery, but you don't get any knowledge you can transfer to a new problem or that can inspire you to do something new, creative, which is a bummer.
Well, have you heard of transfer learning? That's a new application where you can actually train models on one set of data and then try to transfer the knowledge gained in those models to a similar, not data set, but to a similar different problem. So,
Okay,
you know,
interesting.
it's I don't even keep up with it very much. I try to, but it's there's a lot going on in that field very quickly. It's one of those things where I was really into that field like 5 or 6 years ago, and 5 or 6 years have passed and I'm a novice again. Like I have no idea. Like it's moved so quickly that
It's moving
unless
fast,
you're
yeah.
in it full time, I don't think you can keep up.
Based on what I saw at DAFIC, stuff like the auto encoder stuff seems to be really good at morphing, because it's sort of the machine learning approach to principal component analysis or something, right? Like dimensionality reduction. So in that sense, like, I don't know if you consider that glitching, but definitely that type of like morphing parameter space thing. It's interesting.
Yeah.
I look at the stuff and I'm incredibly a novice, but what I see like it's what Julian said last time. I see FIR filters with nonlinearities in the states. And I see, and then they make recursive neural networks, and I see IIR filters with nonlinearities in the state. And I see, having some little bit of background in Bayesian learning, like, you know, they're using expectation maximization to train these things, right? It just took them a while to crack how to train it. But yeah, I see like a really sophisticated nonlinear filter.
I think also, just going back to the creative issue, it's also so I have a background in algorithmic composition as well, and I think that one of the real challenges with like developing kind of more creatively oriented algorithms is just simply that, how do you measure what's creative? You know, it's just a much harder problem. You know, you don't have a lot of exemplars of this thing that you're trying to create, obviously, and so like I think that maybe is a real problem that needs to be solved in it. One thing that I think is a potentially interesting data source is actually musicians using equipment in similar states. So I think actually like the interactions of musicians to build up that data set is actually something that could be really valuable, because, well, we're pretty good at navigating parameter spaces and finding what we like, and we'll tend to stay there when we like it. So I think there could be some ways of kind of maybe providing some sort of automatic labeling for the processes, but not machine learning expert here, but that's my, these are kind of my intuitions. And I think that what happens with a lot of machine learning composition algorithms you'll see is that they'll be very interesting for maybe 5 to 10 seconds, and then it just kind of doesn't go somewhere.
Have you seen the new OpenAI one that's like music in the style of, and they have like full songs in the style of a lot of different people? It's really good. It's kind of, I don't know, scary is not the right word. It's the idea of, it gets close enough to sampling sometimes.
Is that the Rick Astley one? The Never Gonna Give You Up, Never Gonna Let You Down?
Yeah. Oh,
That's
no,
famous.
I think that one's actually different.
Okay.
That was interesting. That was kind of cheating, I think.
Okay.
Because that one was, they trained the neural network on the song itself and then tried to make it play back the song itself, sort of like an autoencoder. So in that case, it's like, well, if the training set is the test set, of course it's going to start spitting out the same thing. But no, the OpenAI one was different. They trained on a corpus of a whole bunch of music from a particular artist and had it write new music in the style of that artist. And it's not, I don't think anyone would buy the record, but the songs are good. I mean, it sounds like music in the style of that artist, and it's generated. It's not, I always thought that the way that this would come about would be there would be a neural network that generates lyrics, and there would be a neural network that generates a melody, and that would all get put together by some DSP. But this is just like spitting out one sample at a time. Could you imagine trying to learn a song by looking at the string of samples? Spitting out the samples?
Yeah.
Not how we think about music as musicians.
So we're sorry, I don't mean to cut you off. We're like an hour and 35 minutes of talking about this stuff with people maybe watching us. They might have trailed off at this point.
Well,
so we should wrap up. But we can stay on and hang out afterwards, obviously. I got this whole bottle of whiskey that I'm not gonna drink anymore, but I'll stay on and chat.
I still have another beer in the fridge. Yeah.
So I don't. You guys, if you want to go around and normally, like this happened last time. Normally, it's like Eventide has like a bunch of artists and stuff, and they're like, "Yo, check me out on this, this, and this." So, I mean, we don't really have that going on here. But if you want to say goodbye, go ahead and I'll call your name. And if all you want to say is bye, just say bye. Otherwise, tell us where we can find you or rep your stuff, whatever you need to do. I'll go in the reverse order. Henrik.
Well, I don't have any kind of SoundCloud or something that I can forward here. So I really just would say bye.
Sweet.
It's also quite late here, so it's almost midnight, and I have to usually get up quite early in the morning.
Yeah, I figured that too. Charlotte.
Yeah, I don't really have anything to plug either. Check out my math courses.
Awesome.
Yeah, thanks for having me. That was really cool.
Yeah, thank you. Dan.
I'm gonna rep Bears.
Sweet.
So bye everyone. It was nice to chat.
Rossi.
Hey, bye everybody. Check out Nero DSP playing. Maybe like.
Cool. Peter.
Bye.
Sean.
Thank you for having us. Nice talking to you all. Check out my Instagram.
And Marco.
I actually was gonna rep Sean's Instagram too.
Oh yeah. Okay. Let's all rep Sean's Instagram.
I have like almost 140 pictures up there.
Ah,
Not too bad.
more than me. Marco.
Yeah, thanks for having a session. It was fun. Could
Yeah.
become a more regular thing, maybe.
Yes.
Yeah. For as long as there's a pandemic, right?
Yeah. And yeah, goodbye.
All right. And I'm just going to say bye. So I think we're good.
Cheers.
We're signing off. Later.
All right. Thank you.
And